Section 8.3 are equations that become quadratic as you start trying to solve them. This is really a good section to review most all types of equations we've worked on this semester. So many different types of equations can be written in the form of a quadratic equation. Quadratic equations, remember, are ax squared plus bx plus c equals 0. We've learned 4 methods so far in this course to solve a quadratic. The zero, factor, actually it's called the zero property, and this is where you can factor. We did the square root property. We did complete the square. And we learned the quadratic formula. Remember, complete the square and the quadratic formula work 100% of the time. They always will work to solve quadratic formulas. 1 will only work if it factors, and 2 will only work if the variable is all within a perfect square. So really, this section is all about first remembering how to solve equations that we have done in other chapters of the course. So if we start with 1, I see fractions. My first necessary goal on this problem is to come up with an LCD to make these fractions agree. That would be x squared. This is over 1. So if I put x squared below 6, I must put it next to 6. X needs to be multiplied by another x to become x squared, so 1x becomes x. Minus 5 over x squared is good to go. Remember also, you have to look to the denominator and know what would make it go to 0. Right? So if you put 0 in for x, you would have 0 in the denominator. So we cannot keep 0 as an answer later on if it shows up. Once we make these fractions all have the same denominator, we peel out and solve the top. We're going to take 6x squared minus x minus 5 is equal to 0. This is now our quadratic equation. So you have to ask yourself, by what method do you want to solve it? It might factor. Do you want to try to factor it? The square root property won't work because we have x's floating around on 2 different terms, so we can't take the square root. Completing the square probably wouldn't be a very easy choice, because completing the square says you can't start unless x squared has a 1 in front of it. We have a 6, so we'd have to divide everything by 6. I would say, how about we use the quadratic formula? So let's use the quadratic formula. That means find A, find B, and find C. A is 6, B is negative 1, C is negative 5. So to find x, we say that negative b, so if b is negative, a negative negative is a positive, so 1 plus or minus the square root of negative 1 squared, b squared minus 4 times a times c, all over 2 times a. So we get 1 plus or minus negative 1 squared is 1. A negative to a negative is a positive. 4 times 6 times 5, well, just break out your calculator, is 120. Over 12. You get 1 plus or minus the square root of 121 over 12. Now, 121 is what we call the discriminant, and it is an integer that is a perfect square. meaning we can fully take the square root of it. This becomes 1 plus or minus 11 over 12. Now we have to split the plus or minus into the two parts that it means. We get 1 plus 11 over 12, which is 12 over 12, which is 1. And we get 1 minus 11 over 12, which is negative 10 over 12, which reduces to negative 5/6. So 1 and negative 5/6 are our answers. Now these nice answers mean that we also could have solved by factoring. So we could have also taken 6x squared minus x minus 5 equals 0, and we could have factored this. So let's see how. Remember, you want to multiply to 6x squared, so I'm going to try 6x and x. Negative 5, I need to multiply to negative 5, so I'm going to try 1 and 5. Negative 5 means my signs need to be different. I'm going to say that this is plus and this is minus, so that would make negative 6 plus 5 for negative 1. Set each one equal to 0 and solve. So x is negative 5/6 and x is 1. By factoring, we get the same exact answers as we got by completing the square. It's just whichever approach makes more sense to you. Now when we go to the second equation, we have a radical. We just learned these in chapter 7. To solve an equation with the radical must first be isolated, which it is. Then you apply the power rule. So you apply a power of 2 to both sides. So this becomes 9y squared equals 66 minus 5y, because squaring a square root cancels each other out. Now this is a quadratic equation. I'm going to set it to 0. I'm going to do 9y squared plus 5y minus 66 equals 0. And I'm going to use the quadratic formula. There's no way I'm going to complete the square on that because I'd have to divide everything by 9. And I'm not going to spend too much time trying to factor that. A is 9, B is 5, and C is negative 66. So y equals negative 5, because it's negative b, plus or minus the square root of b squared minus 4 times a times c, all over 2 times a. Now we do cleanup work with our calculator. Negative 5 plus or minus square root 25. A negative to a negative is a positive. Now we need to multiply 4 with 9 with 66. So we get 2,376 all over 18. Negative 5 plus or minus, we have to add those together. So 25 plus 2376 is 2401. All over 18. Now I usually with my calculator will take the square root of that first and see if you can. So I would say, can I take the square root of 2401? Actually I can. I get 49, which means this is negative 5 plus or minus 49 over 18. Now, with no radical remaining, I have to split the plus or minus and simplify each to the best answer I can get. So I write negative 5 plus 49 over 18, and I write negative 5 minus 49 over 18. So the first one would be 44 over 18, which I'm going to reduce by 2 to 22/9. There's one answer. This one is going to be negative 54 over 18, which I'm going to reduce by 9, right? 54 divided by 9 is 6. So I get negative 6 over 2, which is negative 3. So if we go back, negative 54 divided by 18 is negative 3. So here's our other answer. Again, really, really nice answers that have no radicals remaining and no fractions means that this quadratic would have also factored. If you wanted to think about how does it look if I factor it, 9y squared plus 5y minus 66 equals 0 if I solve by factoring is 9y and y. And I'm going to have 22 and 3, because remember 3 can't go in with the 9. And then that would give me positive 27 minus 22 for 5. And then I can set each one equal to 0. And I can solve. And I get the same exact answers. So this is how you could have done it by factoring. But having learned new methods, if you want to go and use a different one, you absolutely can. Now when we look at our third one, I hope you all recognize the only way to begin this one is by u substitution. So we'd say u is m plus 4. So we'd get 3u squared minus 8 equals 2u. Now it's quadratic. I'd move the 2u over. I'd get 3u squared minus 2u minus 8. Let's see if we can factor it. 3u and u. Let's do 4 and 2. This would be minus, this would be plus. That'd give me negative 6 and positive 4, which would give me negative 2 in the middle. Remember, this has to now go back in to where we see u. So we have 3 times m plus 4 plus 4. And m plus 4 minus 2 equals 0. So I'm going to distribute 3m. 3 to 4 is 12. 12 and 4 is 16. And then this is m plus 2. So I factored by substitution. I'm going to set each factor equal to 0 and solve. So 3m equals negative 16. M is negative 16 thirds. And m is negative 2. Four is one that we have really not really thought of yet. So I'm going to show you how to think about this one by using substitution. Meaning we need to think about what we could put u in for. Here's how we're going to do that. We're going to look at this term right here and we're going to rewrite it. We're going to say it's x to the 1/3 squared. We're going to leave 2x to the 1/3 as given, minus 15 equals 0. Why can we take 2/3 and split it up like that? We are applying an exponential rule called the power rule. When a power is to a power, we multiply. So 1/3 times 2 is 2/3. But the reason why it's better to think of that is because now we can see this goofy x to the 1/3 sits on the first term and the middle term. Just like m plus 4 sat in the first term and the middle term, and we used u. So we're going to use u on this one. We're going to use u to be x to the 1/3. Everywhere we see x to the 1/3, we're going to put in u. So we're going to do u squared plus 2u minus 15 equals 0. Now, this one seems small enough, I'm going to try to factor it. U and u, 5 and 3, plus and minus. Now I put x to the 1/3 back in. It's totally factored, so now I set each individual factor equal to 0. I want to isolate x to the 1/3, so I get x to the 1/3 equals -5. X to the 1/3, if it helps, remember we learned that a fractional power tells you a root, so this is the cube root of x equals -5. How do we solve an equation with the radical? We apply the power rule. So we raise each side to the 3rd power. Those drop out. We get x is -125. The other one, same thing, x to the 1/3 equals 3. If it helps, x to the 1/3 means the same thing as the cube root of x. The cube root of x, you are going to cube. So x is equal to 27. So there are our 2 answers. How did we know we were only going to get 2 answers? Because the highest power we had in the equation was 2. That's why we only get 2 answers. All right. Problem 5 is a lot like problem 4. We need to think about how to fix x to the 4/3 to see it with the same x to the 2/3 that's on the middle term. So here's what we're going to do. We're going to say x to the 2/3 squared. You might say, how's that possible? Well, remember, a power to a power, the rule is to multiply. So if we do a little side work, 2/3 times 2/1 would be still 4/3. So that's how we can split it up. But now it helps us to see that the best way to do this problem is to let u be that repeated, goofy expression. So we're going to take out x to the 2/3 and put u there. So we're going to say 4u squared minus 13u plus 9 equals 0. And this one factors. All right, we're going to get 4u and u minus minus, because if you multiply to a positive 9, that means your signs are the same, both negative. And we are going to do 9 and 1. So we would get minus 4 and minus 9 for minus 13. Now we put x to the 2/3 back in, so we get 4x to the 2/3 minus 9, x to the 2/3 minus 1. Now we set each factor equal to 0, so 4x to the 2/3 minus 9 is 0. X to the 2/3 minus 1 is 0. All right, we're going to get that x to the 2/3 isolated, so we're going to add 9 and divide by 4. So we're going to get x to the 2/3 equals 9/4. Now remember what this means. This means the cube root of x squared equals 9/4. So when we can change it to the cube root, we could then cube both sides. Those drop out. We get x squared equals 27 over 64. Not 27, that would not be right. It's not 3 times 3 times 3, it's 9 times 9 times 9. So we want to do 9 times 9 times 9, and we get 729. Now to get from x squared to x, you have to take the square root. So you take the square root not forgetting your plus or minus, right? And then x equals plus or minus, well, the square root of 64 is 8, and the square root of 729, well, let's just see on our calculator what happens. We get 27. So we have two answers of plus or minus 27/8. Now the other two answers, x to the 2/3 equal 1. So this is the cube root of x squared equals 1. Apply a power of 3. So that'll knock those out. X squared equals 1. Now take the square root, not forgetting plus or minus, so x equals plus or minus 1. So there are 4 answers. Now it might be tricky to recognize why there's 4 answers. It's because originally on the given problem, we had the largest numerator was 4. So that one right there tells us that we should get 4 answers. Last one. We know here that this is definitely 4 answers. Some of us might think I'm going to use the quadratic formula, but the quadratic formula only works, right? So using the quadratic formula only applies to ax squared plus bx plus c equals 0. So notice, it only applies when you have your highest power being 2. So we see on 6 that our highest power is 4, which means we cannot use the quadratic formula, which means that this must absolutely factor. That's our only approach here. So we're going to factor it like we normally would, 2 sets of parentheses. I need to multiply to 12, right? I'm going to use 3x squared and 4x squared. I'm going to have a minus, minus. And then I want to multiply to 2. Well, I've got to put my 2 away from my 4, so let's see if we get 11. Outside is -3, inside is -8. We get -11. Now I'm going to see if either one of these factor again by looking for a difference of squares. The first one, 3 and 2, those are not difference of squares. So this one does not factor again. That doesn't mean we can't finish solving it, it just doesn't factor. 4 and 1, those are both perfect squares, so this one factors again. So we get 2x plus 1, 2x minus 1. So we take 3x squared minus 2, we set it to 0. We take 2x plus 1, and we set it to 0. And we take 2x minus 1, and we set it to 0. The second and third are super simple to solve. X would be subtract 1, divide by 2. X would be add 1, divide by 2. So x equals -1/2, and x equals +1/2. Now, the first one is very much how we started this packet. We see x only written as a square. So I want to work on getting it by itself. So I'm going to write 3x squared equals 2. I'm going to divide by 3. I'm going to get x squared equals 2/3. Now that x is sitting alone as a perfect square, I can take the square root of both sides, remembering to put in my plus or minus. The square root of a square becomes x. And then the square root of 2/3 is everything about chapter 7. I have to write the square root for each 2 and 3. And then which of those radicals cannot stay in that fraction? If you're thinking square root of 3, you are correct. How did we learn to clear it out? We multiply by itself. So x is equal to plus or minus square root of 2 times square root of 3 is square root of 6 over 3. So here are 2 more answers. How did we know we were going to get 4 answers? We had a high power of 4, so here's 1, 2, 3, 4 for our complete set of answers.